Hello everyone, let's now understand the concept of trigonometric identities. So there are total 3 main identities, and besides this we have some sum and difference identities. We'll go step by step. So let's take an example of this has a right angle triangle. What I am discussing now is the main concept from where does these 3 identities come. Okay, so if this is my right angle triangle A, B, C, right angled at B. If I simply use the Pythagoras theorem, what does it say? AC square hypotenuse square is equal to AB square plus BC square. Super clear. Okay. Hypotenuse square, perpendicular square and base. This is what it is. Now, I am dividing all by AC square. If I divide everything with AC square, clear? AC square, this gives me 1. Now, there was a term soh, kah, toa. Clear? This was the thing, and another thing we did was Pandit Badri Prasad har bole sona chandi tole. This was a shortcut. You can opt for any of these things. Now, AB upon AC. What is AB? This is AC, P and B. Okay, P and B. AB square, what we are talking is AB square and AC square. AB square upon AC square, perpendicular square upon hypotenuse square. Perpendicular upon hypotenuse is sine. This is sine square theta. BC and AC. BC is this base upon hypotenuse. This is your cos square. This proves your first identity. What did we do? Pythagoras theorem, dividing everything with AC square, and you will get sine square theta plus cos square theta is 1, which is your identity number 1. We also did the same identity using the unit circle as well, where it says x square plus y square equals to 1. So here sine square theta plus cos square theta equals to 1. First identity is sine square theta plus cos square theta is 1. Now I am dividing everything by AB square. If I am dividing everything with AB square, AB square, AB square, AB square, AB square upon AB square becomes 1. AC square upon AB square. AC is hypotenuse, AB is perpendicular. What is hypotenuse upon perpendicular? Opposite of sine. What is opposite of sine? Cosecant. Cosecant square theta equals to 1 plus BC square upon AB square. BC square and AB square. Base upon perpendicular. Perpendicular upon base is tan. Base upon perpendicular is cot square. Can I also write it like this? I am bringing cot square here. So cosecant square theta minus cot square theta equals to 1. Clear? Now, third one. I have divided with AC, I have divided with AB. Now I am dividing it with BC square. Let it be BC square. Now AC square upon BC square. AC square and BC square. Hypotenuse upon base. Hypotenuse upon base will be opposite of cos, which is secant square. Equals AB upon BC. AB and BC, perpendicular upon base. Perpendicular upon base is tan square theta plus 1. BC and BC gets cancelled. Secant square theta minus tan square theta is 1. Here comes the theorem where we are proving from where does these 3 identities come from this main Pythagoras theorem and this right angle triangle. Sine square theta plus cos square theta is 1. Secant square theta minus tan square theta is 1. Cosecant square theta minus cot square theta is 1. Whenever you are solving the question now and you are taking help of any identity, in a bracket outside just write that identity. Cosecant square theta minus cot square theta is 1. This will help you to remember it for long and you will not forget it. Okay. These are the 3 main and very important identities that we generally use. Now, this identity was clear from yesterday's class. X square plus y square is 1. Sin square theta plus cos square theta is 1. Now, We have heard of a term sector. In which area or in which place you reside? I am a resident of sector 4. I am a resident of sector 7. So sector, you can learn it like this. Secant square theta minus tan square theta is 1. Cosecant square theta minus cot square theta is 1. Clear? After these identities, what next comes is your sum and difference identities, which is at this portion. Alright? Cos alpha plus beta. For example, I have to find cos of 120 degree. Cos of 120 degrees. Now 120 degrees can also be written as 60 plus 60. Cos of 2 theta. Okay, and it can also be written as the sum of two different angles. So these are the sum and difference identities. Any angle can be written as sum of two angles or difference of two angles. Cos alpha plus beta. Cos alpha, cos beta minus sin alpha, sin beta. Okay, now sine. Sine means same. I am writing it like this. Whenever you have sine theta, understand it or learn it like this. It has the same sign or it follows the same sign. Sine of alpha plus beta, it will follow the sign. Sine of alpha minus beta, it will follow the sign. Cos of alpha plus beta, it will not follow the sign. So this is the opposite sign. Clear? Cos of alpha minus beta, opposite sign. Sine does not, no, cos does not follow. Sine follows the same sign. Sine follows the same sign, whereas in the case of cos, the sign gets reversed. Now cos frames the pair. Cos frames the pair. Sine does not frames the pair. Okay. Sine does not has the same pair. It has one sine, another cos, one sine, another cos. Whereas cos has both the cos together, both the sine together. Let's just read it properly. Cos alpha plus beta. Cos alpha, cos beta. This is cos. Sign will get changed. Then cos alpha, cos beta, sin alpha, sin beta. Cos alpha minus beta. Sign will be reversed. Cos alpha, cos beta plus sin alpha, sin beta. Coming to the sign. Sin alpha plus beta. Sin alpha, cos beta. Sign will remain same. Cos alpha, sin beta. At once this alpha is with cos and then alpha is with sin. Beta with cos, beta with sin. Sin alpha minus beta. Sin alpha, cos beta minus cos alpha, sin beta. Clear? Then the last one we have is the identity of tan alpha plus beta, tan alpha minus beta. Listen to me very carefully. There's plus on the top. Whenever there's plus on the top, here top will be plus and the bottom will be minus. Tan alpha minus beta, here there will be minus and here it's going to be plus. That's the relevance of writing it like this. Just learn it like this. I'm writing plus here, I'll write plus and then minus below. Tan alpha plus beta, tan alpha plus tan beta, 1 minus tan alpha tan beta. Tan alpha minus beta, tan alpha minus tan beta, 1 plus tan alpha tan beta. Once we'll do more questions now, this is going to be more clear. But you can copy these identities, these three main identities, and this 1, 2, 3, 4 and 5, 6. 6 sum and difference identities. Okay. Alright, let's now do a few practice questions. Okay. Sin theta is 3 by 5. You have to find cos theta. Now think of an identity where there were sin theta and cos theta both. First identity. Sin square theta plus cos square theta is 1. You have to write the identity always. Don't miss the identity, otherwise you will get more chances of doing mistake. Sin theta is 3 by 5. 3 by 5 whole square plus cos square theta equals to 1. Cos square theta equals to 1 minus 9 by 25. Clear? Now cos square theta equals to 16/25 and cos theta equals to plus minus 4/. Is this clear? Now there's one more thing. The sign, either it's going to be plus or minus, it depends on the quadrants. We discussed this now. Quadrants after school to college, all are positive. Sine and cosecant are positive, tan and cot are positive, cos and secant are positive. So it depends where this cos theta occurs. Okay, first question. It says tan theta is 12/5. Find the value of secant theta. Find an identity where you have both tan theta and secant theta. Sector secant square theta minus tan square theta equals to 1. You have to find secant theta. I'll take this on the other side. So this becomes 1 plus tan square theta. 1 plus tan square theta is 144/25. You can simplify it and you will get the answer. Clear? 169/25. This will give you 13/5. Now next. Cos 45 plus 30. Now this is your double end, sum and difference identities. Cos alpha plus beta. Now cos alpha plus beta. One thing I know, cos frames the pair. Cos frames the pair. That means cos alpha, cos beta, sin alpha, sin beta. Sin. Cos follows the sin? No. So cos alpha, cos beta minus sin alpha, sin beta. Cos 45 sin 30 minus, cos 45, cos 30, sin 45, sin 30. You can put in the values and you'll get the answer. Next, tan 75. Now in that table I had 0 degree, 30 degree, 45 degree, 60 degree. Is there anything else? No. This is asking me 75. This 75 can be written as 30 plus 45. So that means tan 30 plus 45 degrees. I told you plus, here it is plus, I am going to write plus here and there's minus below. Tan alpha plus beta equals to tan alpha plus tan beta upon 1 minus tan alpha tan beta. Through this you can replace alpha with 30 and beta with 45 and find the answer. Is this alright? These were few simple and easy questions based upon those identities. Now this kind of questions comes where you have to prove left hand side is equal to right hand side. Now if this is my equality sign, I have two things. LHS, RHS. Either I am going to take left hand side, do something and prove it equal to right hand side, or I will take right hand side, do something and prove it equal to left hand side. Third option, take left hand side, do something, you will get an answer. Take right hand side, do something and you will get the answer, but those two things should be same. Then also it proves that left side is equal to the right hand side. Now, in the beginning of this ratios and identities, we did that tan theta equals to sine upon cos, cot theta equals to cos upon sine, and there were some reciprocal ratios. Whenever you have this sort of questions, what's the first step? Whenever you see tan, whenever you see cot, just convert them into sine and cos. What I am saying, you see tan theta, you see cot theta, just convert. After their conversions, what you have to do, you have to find the reciprocals if there are any. Convert them and then follow. Okay. For this question, let's see cot and what's the first step? Tan and cot. Just convert. Okay. This cot can be written as cos theta, cos A upon sine A minus cos A divided by cot A can be written as cos A upon sine A plus cos A. Now again I am taking a common LCM, or what I can do is I can take cos A common. If I am taking cos A common out of A, this has the cos A. What is left? 1 over sin A. Minus sign as it is. Cos A comes out 1. Cos A is taken out 1 upon sin A plus 1. Now we have to write it like this in the bracket, that cot theta equals to cos theta upon sin theta. And now one more thing we are using, 1 upon sin theta is cosecant theta. Don't get confused, I told you opposite of C is S and opposite of S is C. For this particular case, how are we going to proceed forward? Cos A will be written as it is. Oh, sorry. This cos A and cos A gets cancelled. 1 upon sin is cosecant A minus 1 upon cosecant A plus 1. Hence, prove LHS equals to RHS. What steps we followed? We first of all converted this cot theta into cos upon sin. And when I am converting this, I have to mention this to the invigilator that yes, I have used this identity, and then I have converted it. Then 1 upon sin theta equals to cosecant theta. I used it over here. I am going to write it in a bracket. Then hence prove that left side equals to the right hand side. You have to look for the right side, that what I have to prove and what all do I have. This is the meant by the operations, where I am taking the left side, I am doing something and I am putting it equal to the right side. Clear? Okay, so this is another question where we have tan theta upon 1 minus cot theta plus cot theta upon 1 minus tan theta equals to 1 plus secant theta cosecant theta. We know that tan theta equals to sin theta upon cos theta. Cot theta equals to cos theta upon sin theta. Let's just convert. Tan can be written as sin theta upon cos theta divided by 1 minus cos theta upon sin theta plus cot theta can be written as cos upon sin divided by 1 minus sin theta cos theta. I am taking a common LCM over here. The top terms remain as it is. Sin theta upon cos theta divided by, this becomes sin theta minus cos theta when I take the LCM upon sin theta plus cos theta upon sin theta divided by cos theta minus sin theta upon cos theta. Then what I am going to do is, these two terms are divided. This is one ratio, this is another ratio, and they are divided. What does it mean? The sign converts into multiply and it flips. You'll get something like sin theta upon cos theta multiplied by sin theta upon sin theta minus cos theta plus cos theta upon sin theta multiplied by upon cos theta. This and this gets cancelled, and here okay, so we just flip this upwards. Cos theta comes up and cos theta minus sin theta comes down. Sin square theta divided by cos theta times sin theta minus cos theta plus cos square theta divided by sin theta times cos theta minus sin theta. This is what I get. The next step I am going to do is, I am going to take the common LCM, where I will write sin theta times cos theta. Cos theta, sin theta, and the inner bracket comes sin theta minus cos theta minus sin theta. I am taking a minus sign common. This becomes minus, so sin theta minus cos theta. In order to take the LCM, this bracket and this bracket is same. So what I'll do is, cos theta is already there. I'll multiply the numerator with the sine theta. This becomes sine cube theta minus. Sine theta is already there. This bracket is already there. So I'll multiply it with cos theta. This becomes cos cube theta. Next is the identity I am going to use, which is a cube minus b cube a cube minus b cube equals to a plus b times a square plus b square plus ab. A cube minus b cube. I am going to write it like this. Sin theta minus cos theta into sin square theta plus cos square theta plus sin theta cos theta. And in the denominator I have cos theta sin theta times sin theta minus cos theta. This bracket and this bracket gets cancelled. Now this is what I have left. I am going to write it upwards at this point. Sin square theta plus cos square theta plus sin theta cos theta, and I am giving this denominator to all the three numerators individually. I am just splitting it upon cos theta sin theta cos theta sin theta cos theta sin theta. This gives me 1. This gives me cos upon sin. What is cos upon sin? Cot theta. This and this gets cancelled. Sin upon cos is tan theta plus cot theta plus 1. Now tan theta is sin theta upon cos theta, cos theta upon sin theta. If I take the common LCM, cos theta sin theta, cos theta is already there. Above I'll write sin square theta. Sin theta is already there. I'll write cos square theta plus 1 is as it is. Sin square theta plus cos square theta is 1. So that means 1 upon sin theta cos theta plus 1. 1 upon sin is cosecant. 1 upon cos is secant theta plus 1. So this is your RHS. This was a big question, but yeah, you have to practice. The more you practice, the more you'll get hands-on for this. Initially question was there. I took the left hand side. I converted everything in terms of sine and cos. Took the common LCM. After taking the LCM, simplified it. This numerator and denominator gets flipped. Multiplication is done. Identity is used. After this identity, some cancellation, and then I have given the common denominator to this. And further, you are going to split it. My target is to make this out of this last statement. Clear? We'll do one more question, then we'll wrap up. So this is what we have to start. We have to prove left side equal to the right side. First of all, I am using the identity. A plus b whole square equals to a square plus b square plus 2ab. So this becomes sine square a plus cosecant square a plus 2 times, I am using a dot, 2 times sine a cosecant. Cosecant theta is 1 upon sine theta. So can I write cosecant theta as 1 upon sine a? 1 bracket plus a plus b whole square, cos square a, secant square a, 2 times cos a, and similarly this is also 1 upon cos a. C and S are opposite. 1 upon cos a is secant a. This and this gets cancelled. So we are left with sine square a plus cosecant square a plus 2 plus cos square a secant square a plus 2. Sin square theta plus cos square theta is 1. So this gives me 1. 1 plus 2 plus 2. Now I am left with cosecant square a plus secant square a. This gives me 5. But I need 7. Also, I don't need cosecant and secant. I need tan and cot. See how we are going to find it. Cosecant square theta minus cot square theta equals to 1. From this, can I find the value of cosecant square A? 1 plus cot square A. Secant square A. Secant square theta minus tan square theta equals to 1. Secant square theta is 1 plus tan square A. Then 5 plus 1 plus 1. 7 plus cot square A plus tan square A, which is equal to your right hand side. What gives you marks is, see how properly everything is mentioned. I need the identity, I have write it over here. I need the trigonometric identities, I have written it on the right side. So this becomes very important that from where does the next step comes, you explain it properly to your invigilator. So this is how we do the questions, where we do the take the left hand side, do some operations and go towards the right hand side. I hope the concept is clear now. Okay. In next class, we will be practicing more questions and moving forward in trigonometry. Hope you like it.